So good morning, everyone. So welcome you another class of CNC. So in the last two classes, we have already discussed about some history behind CNC and NC. What is the working principle? What are the different components of related to the NC and CNC? What are the advantages, disadvantages, applications, and all? Now, in the third class, we will going to discuss about some basic of CNC, which is on coordinate. So this is very important things of CNC, that the what is the machine axis, how you will determine the axis of the machine. So during programming it is very much important, as you some of you have already known that machine axis is very much important during turning, during milling, during drilling, and every kind of operations. Machine axis, the consideration of machine axis, which one is the positive, which one is the negative. Okay, so these are the very important things, so you have to remember these type of things. So actually, axis movement, you if you have seen this figure, you can easily understand what are the axis configurations of the CNC. This is nothing but the all three axes are the perpendicular to each other. So it is like that. And if you consider this is your x direction, this is your y direction, and this is your z direction. Okay, so now actually in you all know, for any kind of three dimensional features, if you want to make simple geometrical features which is three dimensional, you have to have three dimension relative movement. Okay, x y z in the CNC, you have to have some relative movements of x y z. But if you want to make some complex shapes, only the three axis relative movement is not suitable, or you can say it is not sufficient. So for that reason, you have to have another three axis, or maximum of two axis you have to give in the machine axis. So how you will give? So that's why some kind of milling machine, it is called five axis milling. How this another two axis will come? This is the rotational axis. So if you have already understood the x and y and z axis, now you are giving the rotational axis to the x, it is A, rotational axis to the y, it is B, and rotational axis to the z, it is considered as C. So this is the another three axis will come. So this is six axis. But if you can rotate three axis, control three axis with any kind of combination of these three axis, AB, either AB or BC or AC, you can easily manufacture this type of contour shape. So if you can easily manufacture this type of contour shape, you can manufacture with the rotation or with the controlling this five axis, you can easily construct any kind of complex shapes. You need not to control the six axis movement. So five axis is enough. So that's why for any kind of, for nowadays it is actually, I have already in the last class we have already seen that some kind of turbine blades that we have manufactured. So these type of things, it is actually manufactured in the CNC milling or five axis CNC milling now. So if you can manufacture that kind of things, so you will easily manufacture any kind of complex shape which is used in any industries, or in modern industries like aerospace and medical industries, right? So these are the complex shapes used in generally in the aeronautical industry and medical industry. So now this is the some examples: free body diagram of lathe, free body diagram of milling, vertical milling you can say, and this is the horizontal milling machine, and this is the drilling machine. So we have already discussed that the two axis only is there in the lathe. Okay. So this is the x-axis, positive x-axis, and this is the positive z-axis. So you have to understand, or you have to remember, this is the general consideration of the axis, positive and negative. So for that purpose, you have to remember which one is taking as positive and which one is taking as negative. So for that, you have that there is some conventional rule. What is that rule? The rule is, if your machine has some motor, because it is the one table is controlling, so it should have some motor. So away from the motor is always positive. Okay, so if this table is moving like this is your movement, so somewhere motor is here. Okay, so it is constructed here, so away from the motor is always positive. So if this tool post is, this is actually for the tool post in lathe, so actually here actually this is constructed. Okay, so if the away from the motor it is always positive, so this is actually x direction and this is z direction. So always you remember, away from the motor is always positive in any kind of machining systems, and it is also applicable in the CNC. Okay, so away from the motor is positive. Now you will see the in the x, only you have to remember the x and z in the lathe, and xyz in the drilling, as well as vertical milling, as well as horizontal milling. Okay, so this is your x direction in vertical milling, this is your z direction, and this is your y direction. This is your y direction in horizontal milling, this is your x direction, and this is your z direction, and all the positive sign we have taken away from the motor is positive. So it is not actually, that's why it is not given or indicated in the free body diagram, because depending on the manufacturer of the machine, it is dependent where the motor is situated. So actually the programming is like that already. If the controller is provided by the manufacturer, they will provide such a axis configuration like that, away from the motor is always positive. So that's why we have not indicating the free in the free body diagram, the motor placing is not indicating. So you have to remember only that away from the motor is always positive. So this is the thing. So here also the same things for the drilling operation. On the for the drilling operation, sometimes these two axis is not operated, only z axis is operated for the hole, for making hole. Now there are two types of coordinate systems. One is the absolute and another is the incremental coordinate systems. So G90 is the code for the absolute coordinate system, and G91 is the code for incremental coordinate system. So you have to only remember these things are basic. What is the basic of absolute coordinate systems? Absolute coordinate system is always taken from the 0 0 point, which is the origin point of the axis. Okay, so every point, if you consider this 1 and 3, it is from the 0 0. This is -1 and t, this is -1 x direction and 2 positive 2 y direction. This is also taken from the 0 0 point. This is your 0 0 or the origin point. But what is the difference in between incremental and absolute coordinate system? And the incremental coordinate systems, this is your origin point 0 0. First point is calculated from the 0 0 point. This is 1 and 3. This is 1 is positive x direction and positive y direction is 3. But after that, the second point 2 is calculated from the previous point, not from the origin point. Only this is the difference. Okay, so from for the absolute coordinate systems, every points will be calculated from the origin point, and incremental coordinate point, every point will be calculated from the previous point, from the previous point. So for the first point, previous point is the origin point, because this tool is moving from the origin point only. After that, from 1 to 2, the only point 1 will be considered during we will be calculating point 2. So the origin point of previous point is important when we will calculate incremental coordinate system. So sometimes absolute coordinate systems is very much essential, and sometimes incremental coordinate system is very much essential, where when we will program such a simple type of shape. So in our syllabus we only have such simple kind of operation. So for that reason we will always consider G90, because for the simple kind of operation, we if we will calculate every point from the 0 0 point, it will be better for us. But when complex type of shape is there, there are a lot of coordinate points are there, then it will be very difficult to calculate from the 0 0 point. So for that reason, if this type of gear if you want to manufacture, then it will be very much difficult to calculate all the points from the origin point. For that time, you have to calculate the position from the previous one. So that is in the incremental coordinate forward. So you have to only remember that if the questions will come that where is the applications of the absolute coordinate system and incremental coordinate system, yes, you can apply both in all the cases, but there's some specific reason when we will choose absolute coordinate systems, when it will in the simple geometric shape, and if it's a complex geometric shape, then we will consider the incremental coordinate systems. Now three types of machine reference or three types of reference system in CNC we will consider. What are those? One is the machine reference point, that is indicating by M. One is the workpiece reference point. This is also indicating by W. And this is one of the reference point of tool reference point, machine 0 point. This is machine 0 point. This is workpiece 0 point, and this is machine reference point, or sometimes it is also referred as the tool reference point, because tool is situated here. So this machine 0 point and the machine reference point or tool reference point is indicated or established by the producer. Who is the producer? Manufacturer of that particular company who is manufacturing this machine is the producer. Okay, you will not set these two reference point by your own at your own. It will be set by the or established by the producer or the manufacturer of that company. So only those people will know where the machine 0 point and the machine reference point or the tool reference point will be there. There is such a coordinate point. So now what is the, and workpiece reference point only we will set. What is the workpiece 0 point or workpiece reference point? Workpiece 0 point or workpiece reference point is nothing but the from where you are starting your programming, or from where the programming will start. This is the point which you will set. You are the programmer, you will set that point, but these two will set by the M and R will set by the manufacturer of that particular company. So what is the main reason behind it, why you will set that? This is the reason that machine reference point is the point, or tool reference point is the point after machining operation, when we will off the machine, or after one pass, or after doing the total one operation, tool will move to its at its certain place which is far away from the workpiece. Why it is like so? Because it is important, because we will avoid the physical contact in between tool and the workpiece. We will always try to avoid that, because if there is some type of physical contact, it's a single point cutting tool, then this job is very precise. Okay, so this may be wastage, or this may be break. So that's the reason behind it. We will always set some machine reference point or the tool reference point after machining operations. The tool will move to a safe place, when and it will be set by the manufacturer, I have already told, and it has some coordinate point. Suppose this is like minus 20, z will be always positive, then it will be 60, like that, and y will be some coordinate point like 40. So minus 30, 40 and 60 will be the coordinate point. So how you will define that minus 30, 40 and 60, if you have not already given somewhere it is as 0, 0 and 0? So this is the thing, that's why machine 0 point is important. So I have already told that machine reference point and the machine 0 point already set by the producer of that particular company, established by the producer of that particular company. So machine reference point is important because we want to take the tool at its safe place after the machining operation. You have understood. But for that reason, we have to code that particular position with some coordinate point. For that reason, we have to have set some point anywhere in the machine 000, and that point is called machine 0 point. So only for this we will set, we want to set tool reference or machine reference point somewhere. That's why we have to set machine 0 point earlier. So now this is the case. If we will set somewhere the 0 point, and on the basis of that we can set also the workpiece 0 point. This is the fundamental thing. Okay, reference systems. So this is also the case of drilling. Okay, this is your workpiece reference point. You will set this. and this is somewhere far away from the workpiece. Somewhere is the machine 0 point, which is 000 will be set, and this is the tool reference point where after machining operation or after drilling operation here tool will go. So this also set by the producer, and this machine reference point is also set by the producer or the manufacturer of that particular company. So this is, I have already told you. You can see that this is the just elaborated part. And now the one important thing is the interpolation. So what is interpolation? So now I have some coordinate point. So this is my circular and this is my linear. Okay, so I want to instruct the tool to go from one position to another position. Okay, so this, if this is the case, tool will move either this way or this way. So on the basis of that, we have taken two type of interpolation. One is the linear interpolation, when tool will move linearly. So G01 is the code, and if it also move circularly, it may be clockwise, then G02 is the code, maybe counterclockwise, then G03 is the code. So this is the main thing. So five types of actually interpolation is there, but in your syllabus linear and circular is only important, and this helical, parabolic and the cubic are important for the complex shape of products, and it is very much sometimes difficult, okay, to calculate. And linear and circular is only is your syllabus. So this is the linear point, start point and end point. This is your linear interpolation, so it can move, the tool can move linearly. And now this is the circular interpolation. So for the circular interpolation, so you have to give some radius also. When we will make some program, we will that see that how the total things will be mentioned in the circular interpolation. Only G02 is not sufficient. Okay, so you have to mention a start point, end point, G02 also with the radius of the circle. Okay, and sometimes center is also important. If IJK, this type of coordinate system, previously we have mentioned the IJK type of things. Now it is not actually being used. This only the radius of the particular curve is important. This is the circular interpolation. Okay, thank you. We will see you in the next class. Thank you.